Hello everyone. So this is the slide where I had finished in the last lecture, where the different lattice planes like 100, 110 and 111 for the 4 space lattices were drawn and their interplanar distances were calculated. Now our today's topic is how to draw these lattice planes. There have been some difficulties in drawing the lattice planes. So that is why our today's topic of discussion is the procedure how to draw the lattice planes. So what were the conditions for what the imaginary plane could be considered as the lattice planes? There had been three conditions. The first condition was the lattice planes must cover all the lattice points. That means no lattice point should be left uncovered. The second condition of being a lattice plane was that the planes must be parallel. And the third one, these parallel planes must be equidistant. That means the distance between any two planes must be same throughout the crystal. So these were the three conditions for what the imaginary plane may be considered as the lattice planes. And what about the interplanar distance DHKL? If HKL, HK and L are the Miller indices of the lattice planes, then the interplanar distance is DHKL. And if this is a cubic system, then the cell parameter A, B, C are reduced to A, because A equals to B equals to C. In that case, the distance DHKL is A over root over h square plus k square plus l square. So these two things we have to keep in our mind in when we will be drawing the lattice planes and will be calculating their corresponding interplanar distances. Now let us draw the 100, 110 and 111 planes of a simple cube, that is P, face centered cube, that is F, body centered cube, that is I, and C face centered cube, that is C, these space lattices. So let's move to this drawing board. First of all, we have to draw a square. Okay, so we are drawing a square, simple a square, and along with that we are drawing another square. So these two squares back to back we are drawing, keeping a slight distance. Now we have to join them. Okay, we are joining this like this. Here's it. So we have joined them. Okay, now for a primitive, if it is P is primitive, then it should have its 8 vertices with the 8 lattice points. Okay, so this is vertex number 1, this is 2, 3, 4, 5, 6, 7 and 8. So this way you are putting the 8 lattice points on the 8 vertices of this cube, simple cube. Okay, now 110 lattice plane. That means if A, B, C are the 3 axes, suppose this is the C axis, this is the A axis, and finally this is the B axis. So we have to put, this is A axis, this is B axis, sorry, this is C axis and this is B axis. Okay, so ABC 3 axis. So this line is for the A axis, this line is for the B axis, and this line is for the C axis. So 1 0 0 means it will cut the A axis at unit distance, that means A by A distance. That is why it is 1. Okay, so here to here is A distance, but along the B axis it cuts the B axis at infinite distance. That's it. That is, it is parallel to the B axis as well as it is also parallel to the C axis. That is why it is 1 0 0. So the lattice plane should be simply this one, this plane and this plane. Let me shade it. Let me shade it. Okay. So these are the two lattice planes. Okay, so this way we can draw this. So let us move on to the previous picture here. Here you find I have drawn here 2 cubes. So you have to just how to draw 2 cubes. Let's see how to draw 2 cubes. Just draw a rectangle. Okay, just draw a rectangle, but the rectangle should have its length double than its breadth. Okay, it should be like this. This is the rectangle, but the length is double than the breadth. So we have to draw similar 2 rectangles. Okay, then in between I have to draw one line. Okay, this is one line and this is another line. This is another line. Okay, this is the second line. So you can easily do this. Now join the corners from here to here, then from here to here, then from here to here, here to here. All the bases are complete. Now the top surface, here to here and here to here. Okay, this way we are drawing 2 cubes joined together. Okay, now after that we have to put the lattice points. Here is one lattice point. No, this is not the right tool. This one should be better. Yeah, this is one. So this way we have to draw here 8 plus 4, that is 12 lattice points. Okay, 12 lattice points. So 12 lattice points on 2 consecutive cubes joined together. So the planes are very easy to draw, the 1 0 0 planes. What are the 1 0 0 planes? This is the 1 0 0 plane, this is the 1 0 0 plane, and this is the third one. Okay, so these are all applicable for a primitive cell. Okay, so very simple. So this is done. Similarly, this one and this one can also be done. This is 1 1 0, that is, it is cutting the B axis in unit distance and A axis also in the unit distance, but it is parallel to the C axis. So how to draw this? So second time you will draw two rectangles back to back with a slight distance, then just cut it into two squares, 2 into 2, 4 squares, then join the vertices from here to here, here to here, and then put 12 number of lattice points. And we have to now draw 110 lattice plane. So how to draw the 110 lattice plane? Just join these corners, these two corners, okay, and here to here. Here also join these two corners, here to here and here to here. Very simple. Okay, now shade these two planes. This is one plane. Sorry. This is the 110 plane, and this is the 110 plane. Okay, so this is 110 plane for primitive lattice. Now how to draw the 111 plane? 111 plane is this, isn't it? So this picture is drawn again. Now we have to look at the movement of the cursor. Okay, we have to select 3 points, this point, this point and this point, and then draw a triangle. So from here to here, then from here to here, and again from here to here. One triangle done. Okay, next you will draw a parallelogram. Select the 4 points, this point here to here, now here to here. Okay, 3 points, and the 4th point is here to here. This is the 4th point. Now join point number 4 to point number 1. So we have got a parallelogram. Okay, and finally we have to draw another triangle. We have to select 3 points, this lattice point, this lattice point and this lattice points. So just draw a triangle. Okay, this is the triangle, and in addition to this you can draw here another lattice plane also. This is also lattice plane in contact with these 2 lattice points. Okay, so we are actually seeing here 5 lattice points. This lattice point is just touching one lattice point. This lattice plane is touching one lattice point of these 2 cubes. This one touching 3, this one touching 4, this one touching 3, and this one again touching 1. So in total there are 5 lattice planes following all the 3 conditions. They are leaving no lattice point uncovered. They are all parallel and they are all equidistant. Okay, now let us shade them before moving on to the next picture. Here, here, here and here and here. Okay, easy. Just shade them. So very clear, very easy to draw, isn't it? So this way you can draw all the 3 types of lattice planes: 100, 110 and 111. So how to calculate the D value, DHKL value? This is actually A divided by, this is 1, that means root over 1 square plus 0 square plus 0 square, that means root over 1, that is 1. So it is A by 1 equal to A. This is A divided by root over 1 square plus 1 square plus 0 square, so A by root 2. And this is A divided by root over 1 square plus 1 square plus 1 square, that is a root over 3. So very easy to calculate the DHKL. That means excuse me, That means the interplanar distances. Okay. Now how to draw the same things in case of a face-centered cube. So let's move on to face-centered cube. Okay, F. For what? We just repeat this picture for the 3 planes. This is for the 100 plane, and also for 110 we shall draw here another picture. For 111 shall draw yet another picture here. Okay, so this is to be for 100 and this is to be for 110. Now one thing I can repeat here, that the face centers, isn't it? So we have to draw the face centered cubes. These 2 pictures will be actually cancelled, because after having drawn the face centered, we have to copy and paste these 2. Okay, so how to reach up to this part? It is clear to all of you. Now let us put the face centers. Okay, so how many faces a cube has? A cube has 6 faces, and for 2 adjacent cubes they have 1 common, so 1 should be less. 6 into 2 minus 1, that is for 2 cubes there should be 11 number of faces, and hence 11 number of face centers also. So first the top faces. So this is the midpoint of the top face. How to reach at this point? Just draw imaginarily the 2 diagonals of this square. Okay, and the cutting point of these 2 diagonals is this one. So this is the middle point. So at this middle point you just draw a lattice point, and to bring the 3D impression just flatten that point. I have flattened this point to bring a 3D impression. So the top point, top 2 points here. Okay, this is the middle point. Now here the bottom 2 faces. Okay, this is one and this is another one. Okay, so we have 4 face centers, top, 2 top and 2 bottom. Now left right, this is the left, this is the right for the left one, and for the right cube, right hand side cube, this is the left face, this is the right face. So in total this right of the left and left of the right is common. So this is the middle face. Okay, so in total we have 3 faces, and to bring the 3D impression just flatten it vertically. This is one, this is second one, and this is the third one. Okay, simple. Now the front and back, 2 front and 2 back. So the front should be, this is the diagonal and this is the diagonal imaginarily, and they are cutting here at this point. So it should be circular, exact circular. Okay, and you can enlarge it a little because it is in the front part. In the enlarged form. Okay, so this is done. Now the back one. Actually the position of this one is wrong. This is the diagonal and this is the diagonal, so they are cutting at this part, at this point. so it should be moved a little. Let me move it a little here and here. Look. Okay, when you will draw it by hand, then it would be easy to make the perceptions, but in the peripheral presentation, peripheral means on the monitor of a computer, little bit not so easy. Okay, you have to be very much cautious. Now the back face, this is the back face and its center is this one. So to bring the 3D impression, what happened? Oh, I see. Yeah, so this is the middle point. It should be smaller than the front one. Okay, and its position should be the cutting point of the two diagonals. Yeah, this is the cutting point of the two diagonals, and the next one should be here. It should be drawn a little bit smaller to bring the 3D impression. Look, it looks beautiful. So this seems to be present in the front face and this one seems to be present in the back face. Okay, so the lattice plate are, that means the lattice points are drawn, and right now I have to copy and paste this picture. But when you will draw it by your hand, you do not have the provision to copy paste. In that case, you have to do it manually, isn't it? You have to do it manually. So every time you have to draw two rectangles, cut them into two squares, 2 into 2, 4 squares, and then join their corners, put all the lattice points in the 12 vertices, then again the lattice points in the 11 number of face centers. Okay, so you have to do it thrice. I have done it one here. This is the advantage here, but you have to do it thrice when you will be doing it manually. Okay, so 100 plane. Okay, 100, that you know the position of the 100 planes. We have to keep the conditions in our mind, that whether they are being fulfilled or not. Okay, this time I take help of the lines which are thinner to make it more clear, otherwise it would become obscure. So 100 planes, this is the 100 plane, this is the 100 plane, this is the 100 plane, isn't it? So let me first shade it. Okay, let me first shade it. Oh, fine. So these are the three 100 planes. Now if I ask you whether all the three conditions are fulfilled, you would find that the second and third conditions are being fulfilled, but the first condition is not being fulfilled, because the first condition is all the atoms to be covered. No atom should be left uncovered. Here you find the 4 face centered lattice points, the top, bottom, front and back, they are being uncovered. Here also they are being uncovered. So here you have to draw one more lattice plane in between these two. How to do this? Just from the middle point of this edge, join the line to the middle point of the edge of the top back edge, from here to here, like this. Okay, from here to here, like this. Okay, then join these 2 points here to here, and then join these 2 points here to here. Look, all the 4 atoms now being covered, isn't it? Now we have to shade them, but before shading we have to draw the lattice plane here also, here to here, then here to here. Okay, so you must follow the movement of the cursor or the sequence of drawing the lattice points. Okay, and here to here. Okay, one more thing I have to do, just I have to repeat this because I didn't draw it accurately. So the vertical lines to be drawn first. This is optional, whether you will draw the vertical lines first or the horizontal lines first. Okay, so this is done. So these 2 are the lattice points. Now shade it. Okay, so I am just shading it, just filling the color. Okay, when you will do it manually, you can do like this one line. Okay, this is another line, this is another line. So this way you will do it manually, but it will not be done here by me on this monitor, because filling the color makes it more clear to you. Okay, and also it is less time consuming. So we have actually, instead of 3, we have 5 planes, and this plane from here to here, here to here, this plane is cutting the a-axis at half unit distance. So it is actually the 200 plane. It no more remains 100 plane. It actually becomes a 200 plane, isn't it? It actually becomes a 200 plane. So how to calculate the d value, DHKL value? So H becomes 2, K remains 0, L remains 0. Okay. So A divided by root over 2 square plus root over 0 square plus root over 0 square. That means A by 2. And naturally it is cutting at A by 2 distance. So this is also the interplanar distance. So this distance is A by 2. Okay. Now here 1, 1, 0 planes. So just join them. Okay. Joining here to here, here to here, also here to here, and here to here. Okay. And finally shade them. So in order to shade them, this one and this one, this one, this one, and this one. Okay. Finally the 1, 1, 1 planes. So similarly we have to select here to here. Okay, now this is, we have to draw a triangle here to here, here, and finally here to here. Okay, this is one triangle, and you will be surprised to see that this triangle is covering this front face center, this left face center, and this bottom face center. So along with these three lattice points of the three vertices, it is also covering three face centers. Now whenever you will go to draw the parallelogram, here to here, then here to here, okay, then followed by here to here, and finally 4 to 1 again. So in this parallelogram also, this left top face center, the right front face center, the right bottom face center, and the left back face center are being covered. Not only that, the common face between the two, that is the right face of the left cube and left face of the right cube, its center is also being covered when this parallelogram is drawn. Okay, and finally this triangle, it is covering, first look, the right hand top face center, right hand right face center, and finally the right hand back face center. So all the atoms are covered, and the fourth and fifth faces also. Yeah, actually first and fifth faces. Okay, let's shade them to make it clear. This is one, this is one, this is the actually lattice plane number 2, this is 1, this is 2, this is number 3, this is number 4, and finally this is number 5. So in this case all the atoms are covered. Okay, now here you will find one dispute. What is the dispute? All the atoms are not covered. This left of the left cube, left face center of the left cube is not covered. The left face center of the left cube is not covered. The common face is not covered, and here also the right face center of the right cube is not covered. So we have to input one more faces here. So actually I have drawn it earlier because this one was more easy, but this one is very critical. Okay, and the front face center, this one, the back face center, this one, these two are also not covered. This one and this one, they are also not covered. So how to draw them? That is very difficult. Yeah, it is literally difficult, but I'll make it easier. Take this point, this edge, okay, and this is the middle point of the edge. This edge, this is the edge, this is the middle point of the edge. So just join here to here. Similarly here to here. Now this point to this point, join them. So did you understand why I chose this thin line? Otherwise it would have looked so clumsy. This is the edge, this is the middle point of the edge. This is the edge, this is the middle point of the edge. Join them. Join them. And you cannot shade them, because if you go to shade them, it would become very dirty. Okay, Actually it will have to cover this atom, this picture, this atom, yeah, and in between here, here to here, here to here, here to here, and here to here, but it will have to cover this one again. That's all. Okay, so we are here, we can see one lattice plane, 2, 3, 4 and 5. Okay, 5 lattice planes together. In between this lattice plane is covering this atom and this atom. This lattice plane is covering this one and this one. These two, this lattice plane is covering this one and this one. Okay, so this is actually not 110, this is actually 220. This is actually 220. Okay, so this is 220. So finally it becomes 200, 220 and 111. This becomes 220, this becomes 200, but this one remains 111 plane. So similarly, you will draw the lattice planes of the body centered cube and surface centered cube. I don't want to make the lecture so lengthy. Okay, just make it clear here. Here 100 plane becomes 200, and this, in this case 110 remains 110, but in this case 111 becomes 222. So how to draw? So this plane and this plane and this plane, these three are common with these two, isn't it? But in between you have to insert 4 more lattice planes. This one, this one, this one and this one. So just take the middle point of the edges. This is the middle point of this edge. Of this edge, this is the middle point, and of this edge, this is the middle point. So join them. Okay. Here is no atom being covered, but in order to maintain the third condition, to make them equidistant, we have to insert one more plane here. In between these two planes, you have to draw this. So this is the middle point. Okay, this is the middle point. Look at the position of the cursor. This is the middle point. Now in this edge, this is the middle point. Okay, and this is the edge. This is the edge. Here is the middle point. So you are just drawing a parallelogram here. So simple. Here also you draw another parallelogram, and here a triangle. So this way you can draw the 2 to 2 planes. Okay, and by applying the a over root over h square plus k square plus l square formula, you can easily calculate the interplanar distance. The same thing is applied for the surface centered lattice also. Okay, so that's all for today. Thank you very much. Have a nice day.